Okay, so smart building skin systems are the dynamic and responsive exterior envelopes of buildings that adapt to their surroundings and user needs. They are composed of a combination of active and passive components that work together to optimize building performance and sustainability. Each system is designed for a specific need or purpose. Smart building skin systems can significantly reduce energy consumption for heating, cooling, and lighting by adapting to changing environmental conditions and occupant preferences. Smart building skin systems can maintain healthy indoor air quality by controlling airflow, ventilation, and filtration. They can minimize the environmental impact of buildings by reducing energy consumption, material consumption, and pollutant emissions.
Majorly, there are three types of building skin systems, starting with kinetic facade. Kinetic facade are facades that change their appearance or function in response to surrounding environmental conditions. In most of kinetic facades, electrochromic glass is used to tint the windows in response to sunlight. Kinetic facades can improve energy efficiency by reducing the need of heating and cooling, and also they can improve indoor comfort by providing glare control and natural light. Generally, kinetic facades are expensive in terms of installation and maintenance. Moving to the green facades. Green facades are facades that covers the exterior of the building with plants or the other vegetation and helps to insulate the building by converting warm winds into cool air. Green facades can improve indoor comfort by providing fresh air and reducing noise levels that come from outside. And also they can reduce the environmental impact of buildings. Green facades are sustainable and expensive, and the maintenance cost is higher compared to other facades. Yeah, and finally, solar powered facade. In this type of facade, solar panels are integrated into the building and envelope, and they generate electricity to power the building. And the interesting part is these kinds of facades can generate revenue through selling electricity back to the grid. Solar powered facade is capable of reducing buildings' carbon footprint. They also reduce the environmental impact of buildings. Solar powered facades can improve the energy efficiency of the building. These types of facades are generally expensive facades and they need maintenance for sure. And for installation, they generally need skilled labor that costs high.
So another type is the algae producing facade. There's an existing one located in Germany. From the findings of Hanafi, they suggest that the carbon emissions with this system can be decreased and the electrical energy consumption can be lowered by 45 to 50%. Direct sunlight stimulates the rapid growth of the small cells. Algae is a very fast growing organism. Through this growth, it generates heat and uses that in the building. The next example is a metal mesh that reacts to heat. This is also called a thermobimetal building skin. It was first proposed by Doris Kim Sung. It's typically done by using two different metals with vastly different coefficients of thermal expansion. That way, one side expands quicker and more than the other side. It causes a curling effect. That curling effect opens air vents and allows the hot air to be released. When the temperature cools back down, those vents close and it has an insulating effect.
A facade that eats smog. It was constructed in 2011 in Mexico for a hospital, general hospital. It's based on the principle they use the Prosol 370E tiles, which has a titanium dioxide as a main ingredient, which effectively scrub the air of the toxins by releasing spongy free radicals that could eliminate pollutants. By constructing these, the Mexico City can mitigate the impact of almost 1,000 automobiles like cars. The light responsive facade that breathes. It was in Abu Dhabi, the pair of towers, which has a thin skin of glass, and the screen operates as a curtain glass, and which is 2 meters away from the main building, and it is on an independent frame. It moves according to the movement of the sun, and it closes at the night. The living leaf as a skin. It's a Habitat 2020 building in China, and it radically alters the perception of we usually use inert materials as a construction, but for this one, the exterior has designed as a living skin rather than the inert materials. The skin behaves like a membrane which serves as a connection between the exterior and the interior of the habitant. Alternatively, the skin may be considered as a leaf surface, having a similar stomato, like cellular openings involved in gaseous exchange and transpiration in plants. It works like the surface would allow the entry of the light, air, and the water into the housing. like it automatically positions itself without any support based on the sunlight, and it will let the light in, thus electricity, thus which can convert the electricity. Benefits of this smart building skin systems: environmental benefits, like it improves the ecosystem and enhances the quality of the air and protects natural resources. Economic benefits are operating costs will be decreased, like even though the initial costs are high, but the operating costs will decrease. It enhances the thermal, acoustic, and air conditions, which contributes to the overall quality of the life.
Yeah, so the potential of smart building skin systems to optimize energy efficiency, occupant comfort, and indoor air quality is driving their adoption in new and existing buildings. With advancements in technology and design, smart building skin systems are poised to play an increasingly important role in creating high-performance, sustainable, and occupant-centric buildings of the future.